right, class, now we're going to talk about how to graph these rational expressions. I've already been calling them functions, so we know because they are functions that they pass the vertical line test, which tells us quite a bit about them. We've figured out how to find their domains, so let's take a look. So remember, our rational functions are of the form p over x, p of x over q of x, and that our denominator can never equal 0. These are rational functions. The domain of rational equations is the intersection or the overlap of each of the rational expressions in the equation. So now I need to find the domain by setting each of the denominators equal to 0. Now we can ignore this constant term because its denominator will never equal 0. So I have x equals 0 and 2x equals 0. Well, x equals 0 and 2x equals 0. We need to divide both sides by 2. So I just have x equals 0. Okay? So the domain of this rational function, I'm going to write it in set notation, is x such that x doesn't equal 0. So the domain is every single number except for 0. Now let's take a look at this function. So I need to set each denominator equal to 0, and I need to switch pen color because that green is just really something. How about pink? So I'm going to set each of my denominators equal to 0 and factor them to figure out what values we must exclude from our domain. So this gives me x minus 3 equals 0, x plus 3 equals 0, and x squared minus 9 equals 0. I add 3 to both sides. I get x equals 3. I subtract 3 from both sides. I get x equals negative 3. But I need to factor this quadratic over here. We can see that this is a difference of perfect squares. I have x squared, and then I have 9, which is 3 squared. So I'm going to factor this into x plus 3 times x minus 3 equals 0. Then I use the 0 factor property to set each of my factors equal to 0. And I also get that x equals negative 3 and x equals a positive 3. So my domain for this rational equation is going to be x such that x does not equal negative 3 or positive 3. Now, what if I want to solve this rational equation? So the first thing I need to do is find the domain. We found 2 slides ago that the domain of this is all values of x except when x equals 0. Next, we need to multiply by the LCD in order to eliminate denominators. Then we're going to solve and check that each solution is in the domain. Okay, so the LCD, that's the lowest common denominator. So it's going to be the smallest number divisible by x, 2x, and 2. So in this case, the LCD is just 2x. Okay, so I'm going to multiply both sides by 2x. And this will cause my denominators to cancel. I have 2x times 2 over x. That gives me 4x over x. 2x times negative 3 over 2 gives me negative 6x over 2. And 7 over 2x times 2x, that gives me 14x over 2x. And if we can simplify these functions, we'd see our denominators will cancel. This leaves me with 4 minus 3x divided by 2 just gives me 3x equals 14x divided by 2x. My x's cancel. 14 divided by 2 is going to be 7. To solve this, I subtract 4 from both sides. I get negative 3x equals 3. I divide both sides by negative 3. I get x equals negative 1. Now I need to check, is x equals negative 1 in my domain? Yes. So our answer to this, the solution to this rational equation, is x equals a negative 1. Now for this next example, we had found that our domain was all x values except when x equals negative 3 or 3. I need to figure out next what the lowest common denominator is. I know that this is going to factor into an x minus 3 and an x plus 3. We are lucky enough in this case that this is going to be our lowest common denominator because I need a factor of x minus 3 and a factor of x plus 3. So we're going to go ahead and multiply both sides by this. So I multiply by x minus 3 times x plus 3. And on this side as well. That's going to give me 2 times x minus 3, x plus 3. I know my x minus 3's are going to cancel, so I have 2 x plus 3. I then have negative 3 times x minus 3, x plus 3. I know these x plus 3's are going to cancel, so I have negative 3 times x minus 3 equals 12 over x squared minus 9, which I know is equal to x minus 3, x plus 3. So my denominator here is going to cancel, and I'm left with a 12. Feel free to write that out in every step in its entirety. I'm doing it for the sake of space. So now I need to go ahead and distribute. 2 times x gives me 2x. 2 times 3 gives me 6. Negative 3 times x gives me negative 3x. Negative 3 times negative 3 gives me a positive 9 equals 12. What's really nice is this is an equation in one variable. So now I just combine like terms. 2x minus 3x gives me a negative x. 6 plus 9 gives me 15 equals 12. I subtract 15 from both sides. I get negative x equals negative 3. I divide both sides by negative 1. I get x equals negative 3. Uh-oh. Now I need to check that each solution is in the domain. Is x equals 3 in my domain? No, it is not. So this has no solutions.